Okay, this is the first video on lesson 3.6, the Cauchy criterion. And so let's start with, we'll get back to this graph here in a moment. And so let's take a look at, first thing we're going to discuss is convergence. Okay, and so with convergence is where we have a sequence such as x sub 1, x sub 2, x sub 3, x sub n, and that goes on. Converges to a limit, L for every epsilon greater than 0, there exists a positive, there exists an n, which is an element of the positive integers, such that the absolute value of our sequence x sub n minus the limit is less than epsilon whenever our n for our sequence x sub n is greater than our number n that we set. So basically what this is saying here is, here we have a sequence, and we have a sequence that converges to a certain limit, but when we don't know what that limit is, then what we have to look at is we have numbers that basically the sequence is coming up and down like this and getting smaller and smaller. So we'll call the top numbers in the sequence x sub n, and then we also have x sub m. So these sequences, as n tends towards infinity, this sequence starts to converge. Well, we want it to converge within this epsilon. Well, that's where the uppercase n comes in, is we set a boundary where, okay, anything past this will have a sequence that's within this epsilon. So as it converges further and further, we can look at that. So we're looking at x sub n over minus x sub m, and absolute value of that is less than epsilon. Okay, so suppose we're given a sequence and want to examine the possible convergence. That's what this is. Whenever we're not given a limit, so we're not given a limit here, then the above convergence technique can't be used, because we don't know what the limit is, so we can't use this technique we can't use x sub n minus L. So that's where the Cauchy sequence comes in. So with the Cauchy sequence, that's where we have an infinite sequence, an infinite sequence, x sub n is called a Cauchy sequence. Is called a Cauchy sequence. If and only if for all epsilon that's positive, there exists an n that's an integer, a positive integer, such that the absolute value of x sub n minus the absolute value of x sub m is less than epsilon. For all m greater than n and all n greater than n, uppercase n. Okay, so we're going to, on the next video, we're going to take a look at the proof on that. And so this concludes this particular video.